Okay, let's continue the Chapter 1 review worksheet, and this video starts with number 14. And number 14 is limit as x approaches 19 of this function. If you plug in 19, you get 0 on the top, and then you get 5 minus the square root of 19 plus 6. That's 5 minus square root of 25, so you get 0 over 0. Always make sure you plug in first. Since we got 0 over 0, we know there's work to do. And the easiest thing to do when you see a radical is to go ahead and see if you can multiply by the conjugate. So let's multiply the top and bottom by the conjugate, which is 5 plus the square root of x plus 6. Do that to the top and bottom. And why do we do that? If you remember, there's a formula that says a squared minus b squared factors to be a plus b times a minus b. So if you look here, this is now our a minus b. This is our a plus b, and we don't even have to like FOIL it out. We know that it's going to be a squared minus b squared. And notice I could take this whole radical sign and say that it's b. So what's a squared going to be? Oh, by the way, we have to continue our limit notation. A squared is going to be 25 minus b squared is going to be x plus 6, right? Because when you square a square root, you get the function. And then on top, we're going to have x minus 19 times that part of the conjugate. Sorry, this is getting squished. Okay, so let's rewrite that so you can read it and so that we clean things up a little bit. Again, we continue the limit notation. And on the top, or the bottom, however you're doing it, the part that doesn't end up being a squared minus b squared, I always say don't multiply it out unless you have to. So let's just leave it as x minus 19 times 5 plus square root x plus 6. And I'm going to double check and make sure that's positive. I didn't mess up my signs. And on the bottom, I'm going to distribute this negative. So I have 25 minus x minus 6. That worked out really well, didn't it? Because that's going to equal, on the top, x minus 19. On the bottom, I see negative x plus 19. And then, of course, we have the 5 plus root x plus 6. So the only issue we have now is that the signs are reversed right here, aren't they? We have, what we really want this to be is positive x minus 19. Well, there's a cool little algebra trick you could do where you actually factor out a negative 1 and it changes the signs. So what we can do here is we can do limit as x approaches 19 of, we'll keep the numerator. It doesn't really matter if you do it to the numerator or denominator. And in the denominator, let's factor out a negative 1. Well, that makes this a positive x, and that a negative 19. You see what I mean? If I distribute this negative 1, I'll get this again. So that's completely legal. Okay? This, negative 1 times x minus 19, is exactly the same as negative x plus 19. So now we're ready to cancel. These cancel, and we're left with, again, I'm carrying my limit notation, 5 plus the square root of x plus 6 over negative 1. So what is this? If I fill in the 19, I get 5 plus the square root of 25 over negative 1. That's 5 plus 5 over negative 1, so that's negative 10. And notice here, I didn't need my limit notation because I was done with my x's. Okay, wow, that was a long one. Let's do number 15. Remember, the first thing you always want to try is plug and chug. So let's say this equals 3 minus 3 over 3 plus 4. Just filled in for x. And I get 0 over 7. That equals 0. Remember, a 0 over a number equals 0. Please don't leave it like this. Please write 0. All right, that one was great. All right, let's do some trigonometry here. Number 16. The limit as x approaches 11 pi over 6 of cosine x. So if you don't have this trig value memorized, what's a quick way to get it on the test? Well, draw your cosine picture. And let's put in the important values. Here's pi over 2, pi, 3 pi over 2, and 2 pi. And 11 pi over 6 is going to be very close to 2 pi. It's going to be up here, so it's going to be positive. And hopefully you've memorized that any cosine value that has a 6 in the denominator is square root of 3 over 2, right? You might know that from your 30, 60, 90 triangle. So this is going to be square root of 3 over 2, and it's going to be positive. Done. And let's look at number 17. The limit as x approaches pi over 2 of tangent x. I'm kind of hoping that you just know this one. But on the off chance that you didn't, let's go ahead and use our sine and cosine. So it'll be the limit as x approaches pi over 2 of sine x over cosine x. That's going to equal the limit, x approaches pi over 2, of sine pi over 2. See how I'm filling this in now? Over cosine pi over 2. And actually, since my x's were gone, I wouldn't necessarily have needed to rewrite the limit statement, I guess, that time. So that equals, what is sine of pi over 2? Well, that is 1. What is cosine of pi over 2? Well, that is 0. Therefore, this limit does not exist. If you remember your cosine graph, it does this, right? And pi over 2 is where the asymptote is. And 3 pi over 2, and so on. Okay, limit as x approaches 2 pi over 3 of sine x. And if you don't have these memorized, you can draw a quick sine graph. Mark your important values. Here's pi, 2 pi, pi over 2, 3 pi over 2. Of course, this is 0. This is our y-axis. Okay, so hopefully you've at least memorized that all of the sine values that have a 3, or all the radian values that have a 3 in the denominator, result in a sine value of square root of 3 over 2. You may remember that from your 30, 60, 90 triangle. And if we look here, 2/3 is going to be somewhere around here, right? It's on the way to pi. That's positive. So there we go. Square root of 3 over 2. Limit of 8 cosine 3x. My goodness, what do we do with this? Well, first thing, let's just get the 8 out of there. 8 times the limit as x approaches pi over 4 of cosine 3x. So what I'm basically saying is we'll multiply the 8 at the end. Okay, so that's completely legal to take a constant out. You couldn't take something with an x out, but you can take a constant out. Okay, so let's just plug in now our pi over 4. So that's going to equal 8 cosine 3 times pi over 4. And you know what? I'm going to add some parentheses here so we don't get mixed up. Now notice I don't have any x's. That's why I stopped the limit notation. So that's 8 cosine 3 pi over 4. How do you solve this? You need to know what cosine of 3 pi over 4 is. And hopefully you remember that all the cosine and sine values with a 4 in the numerator denominator, I'm sorry, are square root of 2 over 2. And hopefully remember, here's pi over 2, here's pi. So 3 pi over 4 is going to be here. We're in negative land. So it's going to be negative square root of 2 over 2. And we have to multiply it by 8. So we have 8 times that. These are going to cancel, give us a 4. So that's going to equal negative 4 square root of 2. See, these aren't bad if you know your trig values. Number 20. All right, speaking of not too bad if you know your trig values, cosecant of 5x. So the first thing, you could either go ahead and say that cosecant is 1 over sine, or you can plug in first. It really doesn't matter, assuming that you don't have the cosecants memorized. So let's just do it this way. It's the limit as x approaches pi over 6 of 1 over sine 5x. Okay, so let's plug in. It's going to be 1 over sine 5 pi over 6. Okay, you may remember that all your sine values that have a 6 in the denominator are going to be 1/2. And if you remember your sine graph, all the way up to pi we're positive. So 5 pi over 6 is still positive 1/2. So we can say that this equals 1 over 1/2. Now you may know that 1 over a number just results in the reciprocal, but if you forget that in a test situation, you could say that's the same as 1 divided, remember the fraction line is a dividing sign, 1 divided by 1/2. And then you can do keep, flip, change. Keep this, change the second, or flip the second number, change to multiplication, that equals 2. Okay, or you could have just flipped this denominator and gotten 2. So there's your answer. 21. Okay, looks like we're out of the trig for a minute. How are we going to solve this one? First thing is we better plug in and see what we get. We get, let's put some numbers in. 25 minus 40 plus 15 over 5 minus 5 is 0. So 25 minus 40 is negative 15 plus 15 is 0 over 0. So there's more work to do. So let's factor this. Since we got 0 over 0, that's a pretty good hint that x minus 5 is probably a factor. But let's say you're having a little trouble with your factoring. You can always go back to the x. So for the x, you're going to do a times c and put that on top. This is quadratic factoring, right? You're going to take b, negative 8, and put it in the bottom. So you want numbers here that multiply to be a and add to be b, or multiply to be a times c and add to be b. So 5 and 3 come to mind. How about negative 5, negative 3? And if your a is 1, this is all you need. Okay, I tell the freshmen, if a is 1, do the x and you're done. So we're done. We had x minus 5, x minus 3. We can cancel that. So our new limit is the limit as x approaches 5 of x minus 3, which gives us 5 minus 3, 2. 22. Okay, let's plug and chug first. We'll get 21 over 0. Well, it's not 0 over 0, so we don't have more work to do. We have a number over 0, means that this does not exist. You may also know that that means there's going to be a vertical asymptote there. Okay, that's it for this video.